This is the first of two videos on how to calculate the length of a missing side in a right angled triangle using our trigonometry, so using our three trigonometric ratios. In the previous videos we've had a look at how we label up the sides of our triangle and how we identify which one of the three ratios we're going to need to use to solve a particular problem. We're going to need both of those skills today. We're going to start off with the example here. So we've got a right angled triangle. We've got an angle of 42 degrees. We've been given the base length is 6 centimetres and we're trying to work out the height of the triangle, this value x. So I'm going to start by labelling my triangle. I'm going to draw my arrow away from my right angle. It's going to point towards my hypotenuse, and I'm then going to stand in the corner with my 42 degrees. The wall that I can't touch, this one over here, is my opposite side, and the third side next to my 42 degrees is my adjacent side. We're then going to work out which two of those three sides we're actually interested in. So at the moment we've been given the length of the adjacent side, 6 centimetres. We're trying to work out the height, this value x, so we're going to need the opposite side. The hypotenuse we don't know the length of and we've not been asked to work it out, so we're not interested in h. So I can automatically get rid of the two ratios that have got the hypotenuse in. So the sine ratio, that's no good to me. Cosine ratio, that's no good to me. I know I'm going to be using my tan ratio. Tan is equal to the opposite over adjacent. Opposite, the value I'm trying to work out, my value x, and the adjacent, 6 centimetres. I'm going to start off by writing down my formula. So tan of A is equal to O over A. It's really important that you do that for each of your questions. And then I'm going to substitute my values in from my particular triangle. So I've got the tan. The angle in this particular case is 42 degrees. So tan of 42 degrees is equal to my opposite side, in this case the value x I'm trying to solve for, divided by my adjacent side, which is 6 centimetres. So tan 42 is equal to quite a bit of work. I've labelled my triangle up, I've worked out, I've identified the ratio that I want to use, tangent in this case, substituted my values in, I've picked up quite a few method marks. Remember what we've got here so far is we've got a number 6 and tan 42. Tan 42 I can just put into my calculator and it's going to give me a value. So tan 42 times 6 would just be a number. So I'm almost there. I've got x divided by 6, but I don't actually want that. I want to know what x is on its own. So I'm looking for x. So I need to do the opposite of dividing by 6. I need to multiply both sides of my equation by 6. So 6 times tan of 42 degrees is equal to my value x. Now I can get my calculator, switch it on. I'm going to put in 6 times tan of my angle, which is 42 degrees, close my brackets off and press. So my x is equal to 5.4022 decimal places. There's another way that we can look at that, and that's by using the triangles that we've got here, and they're very much like our speed, distance, time triangles. They work in the same way. So I'm trying to find a particular side. In this case I'm looking at the opposite side. I'm going to cover the O up, and it's going to tell me that the opposite, to find the opposite, I'm going to need to multiply the tan of the angle by the adjacent side. So I'm going to get my x value is equal to my adjacent side, which was 6 centimetres, multiplied by the tan of my angle, which was 42 degrees. And I've got the same expression here, so 6 times tan 42 is equal to x. Just flip that round, x is equal to 6 times tan 42, and I'm going to get the same value that I did before, 5.40. Some people find that easier to work with. I'm just going to pause there and we'll have a look at another example. Okay, here's a second example. So we have another triangle, another right angle triangle. We've got an angle of 32 degrees. and we've got a length of 4 centimetres. I'm going to start, as I did with the previous example, by labelling it up. So I'm drawing an arrow away from my right angle. It's my hypotenuse at 4 centimetres. Stand next to my 32 degrees. This must be my opposite side, and my adjacent, the third side, next to my angle of 32 degrees. Again, I'm going to work out which two of the three sides I'm interested in. So I've been given the hypotenuse at 4 centimetres, definitely want that one. I'm trying to find out the height of the triangle, my value x, so I'm going to need my O value. I haven't been given A, and I haven't been asked to work it out, so don't want A. So I can immediately get rid of the two ratios that have got the adjacent side in. So I can get rid of the cos, and I can get rid of the tan. In this case, I'm going to be using my sine ratio, opposite over hypotenuse. So the opposite side, this x value that I'm trying to calculate, and the hypotenuse at length 4. So I'm going to write down my formula. Sine of A is equal to O over H, and I'm going to substitute my values in from my triangle. So sine of 32 degrees is equal to the opposite side, which is my x value that I'm trying to calculate, and I'm going to divide it by my hypotenuse, which is 4 centimetres, x divided by 4. Again, we're getting quite close now. We're just going to try and work out what x is on its own. At the moment we've got x divided by 4, so I need to do the opposite operation of dividing by 4, which is to multiply both sides of my equation by 4. So if I do that on the right, I've got x. On the left hand side, I've got 4 lots of sine 32. I'm going to go to my calculator, and I'm going to type in my 4, and I'm going to multiply it by my sine of 32, close my brackets, press my equals button, and that's got me a value of 2.12 to 2 decimal places. Okay. Again, we can have a look at our triangles. In this case, we're using the yellow triangle, the sine triangle. I'm trying to find the opposite side again. So if I cover the opposite up, it's going to tell me that the opposite, I'm going to find it by multiplying the sine of the angle by the hypotenuse. So the opposite side, which is my value x, is equal to my hypotenuse, which is 4 centimetres, multiplied by the sine of the angle, which is 32 degrees. Put that into my calculator and I get the same value, 2.12 to 2 decimal places. When I'm writing these expressions down, I always put the number in front of the trigonometric function, the sine, the cos or the tan. The reason for that is it's really confusing if you were to write this value down. So if I wrote sine of 32 times 4, let's have a look on the calculator what we get. So let's clear that. Sine of 32 times 4, I close my brackets, I've got a value of 0.788. It's definitely different from this 2.12 value that I calculated earlier. What I've actually done is worked out the sine of 32 times 4, which is 128, the sine of 128 degrees. That's not the same as if I were to delete these and do the sine of 32 multiplied by 4. The sine of 32 times 4, 2.12. So to avoid that confusion, it's much easier to write your expressions as the number multiplied by your ratio. If you write it that way around, there's no danger that you'll enter the wrong thing into your calculator. So x is equal to 4 lots of sine 32, and we've got our value of 2.12.